A warm hello to you all. Welcome back to my channel. I'm posting a video after a long time on my YouTube channel. The objective is to start a lecture series on distillation, and this will be the first lecture in that series. And in coming lectures, I'll be talking about various important aspects of distillation. In this lecture, I'll be talking about fundamentals of distillation. Okay, so let us start our discussion. I have given uh, title to this lecture as Distillation Part 1, and we will be having number of parts like this in coming days. So this is Distillation Part 1, and in this we are going to get an introduction to distillation. We will be understanding fundamental aspects of distillation. So let us begin with asking ourselves this question: what is distillation? So in this lecture, let us try to get an answer to this question. What is distillation? First point that we can write for this is it is a unit operation. Distillation is a unit operation. Now what is a unit operation? Let us understand this. All chemical engineering operations, they fall into categories, or they can be placed into categories. In category 1, we have those operations which involve only physical changes, whereas in category 2 we have those operations which involve both physical and chemical changes. Operations that involve only physical changes, those operations are called as unit operations, whereas operations involving both physical and chemical changes, they are called as unit processes. And since distillation is a unit operation, distillation involves only physical transformation or physical changes. Then second point that we can write for distillation is it is a mass transfer operation. What is a mass transfer operation? Let us understand. Mass transfer operation is that operation whose objective is to separate components of a solution, of a liquid solution or a gas mixture, and in doing so it results in change in composition of that solution or the gas mixture. So this operation is called as mass transfer operation in which components of a liquid solution or a gas mixture are separated and which results in, or which brings about, change in composition of that liquid solution or the gas mixture. So these operations, such operations, they are called as mass transfer operations, and distillation is one such operation. Distillation separates components of a liquid solution and it brings about change in composition of that liquid solution. This mass transfer operations are totally different from purely mechanical separation operations. For example, sedimentation. In sedimentation, you know, the particles that are suspended in a liquid, they get separated according to their size or based on difference in their densities. But we cannot call that as mass transfer operation because it will not result in change of the composition of the original liquid solution. Okay, so we are saying that distillation is a mass transfer operation. So it is used for separating components of a liquid solution. What is the application of distillation? Distillation is employed to separate components of a liquid solution. When you have a liquid solution, that means there will be more than two components in it, two or more than two components in it. And if you have to separate those components, then distillation is one choice. Distillation is one choice. So basically, distillation is used for separating components of a liquid solution. Now let us understand this. Let us for understanding, let us consider a liquid solution of two components. Let us say component A and component B. ठीक है? So component A and component B, uh, this will form a binary liquid solution. So we are considering a binary liquid solution. Now this components in a liquid solution, they have different boiling points. So in our case, in our example, where there are only two components A and B, component A will be having its own boiling point and component B will be having its own boiling point. Okay. So components of the liquid solution, they have different boiling points. Some components have relatively low boiling points, while some components they have relatively high boiling points. Okay. So what can you say about components with relatively low boiling points? Components with relatively low boiling points, they are low boiling components. They are more volatile and they vaporize early. Okay. So components with relatively low boiling points, we are calling them as low boiling components. They are more volatile. That means they show a greater tendency to go into vapor state and therefore they vaporize early. On the other hand, components with relatively high boiling points, we call them as high boiling components. They are less volatile and that's why they will vaporize late. That's why they will vaporize late. Okay. So all the components present in a liquid solution, they will have different boiling points. Some of them will have relatively low boiling points and some of them will have relatively high boiling points. Relatively low boiling points, those components we call them as low boiling components. They are more volatile and they vaporize early. On the other hand, components with relatively high boiling points, they are high boiling components, they are less volatile and therefore they will vaporize later. Okay. So basically, if you must have understood, the basis of separation in distillation is difference in boiling point. How the difference in boiling point is used to separate the components, let us understand. So in distillation, what is done? Now let us talk about the operation. In distillation, the feed is a liquid solution. Since objective is to separate components of a liquid solution, feed to a distillation operation is a liquid solution. So what is done? This liquid solution, the feed liquid solution is boiled to create a vapor phase. So when you boil the liquid solution, a vapor phase will be formed. And what can you say about this vapor phase? This vapor phase is reaching low boiling components. Low boiling components being more volatile, they will vaporize early and they will quickly go into the vapor state. That's why the resulting vapor phase, when you boil the liquid solution, the resulting vapor phase, it is reaching low boiling components. Okay. Then what is done? The vapor phase that is formed by boiling the liquid solution. The vapor phase is condensed to a liquid solution. Vapor phase, it is condensed to a liquid solution. And what can you say about that liquid solution? This liquid solution will be rich in low boiling components. Since we are just condensing the vapor which is rich in low boiling components, the resulting liquid solution will also be rich in low boiling components. And this particular solution in distillation, this solution, it is called as the top product, or it is called as the distillate, or it is called as the overhead product. The residual liquid, the original liquid solution from which vapor phase is created, after this, it will be transformed to what we are calling as residual liquid solution. The residual liquid solution, it is removed as bottom product, or it is also called as residue. The residual liquid solution, it is removed as bottom product or the residue, and of course it will be reaching high boiling components. because majority of low boiling components, they go into vapor phase, and when vapor phase is condensed, they go into distillate. Whereas majority of high boiling components, they remain in the residual liquid solution, which is the bottom product or the residue. Thus, boiling followed by condensation. So if in this operation we are first boiling the liquid solution, and then we are condensing the vapor phase. Okay, so these two operations, boiling followed by condensation, it tend to separate high and low boiling components. We are able to separate high boiling components from low boiling components to some extent. Okay, that's why we are saying that boiling followed by condensation, it tend to separate high and low boiling components. Okay, now if just one boiling once and condensing once, it will result in limited separation. So you can increase the degree of separation. How to increase the degree of separation? Let us understand. The degree of separation is increased. It is increased by repetitive boiling and condensation. So if you cause repetitive boiling and repetitive condensation, you can increase the degree of separation. More and more low boiling components will go in the distillate, and more high boiling components will go into the bottom product. And for that, we need to carry out repetitive boiling and condensation. Okay, then the purity of the distillate. The purity of distillate is decided by concentration of the low boiling components in it. More is the concentration, more will be more pure will be the distillate or the top product or the overhead product. Okay, so therefore we are saying purity of the distillate, it is decided by concentration of low boiling components in it. And on the other hand, purity of the bottom product, it is decided by concentration of high boiling components in it. More is the concentration, more pure is the bottom product. Okay, so this is how distillation operation is carried out. Simply, liquid solution is boiled to create a vapor phase. The vapor phase is rich in low boiling components, that is, it is rich in more volatile components. The vapor phase is then condensed to get a liquid solution. This liquid solution, we call that as distillate or the top product or the bottom product. Whereas the residual liquid solution, it is removed as bottom product or the residue. Bottom product or the residue, it is rich in high boiling components or it is rich in less volatile components. Now let us understand uniqueness of distillation. What is the uniqueness of distillation? Here, if we compare distillation with other operation, then how is it unique from other mass transfer operations? So let us understand. As compared to other separation methods, so you have gas absorption or liquid extraction. So as compared to this separation methods, no foreign substance is added in the distillation. No foreign substance is added in distillation. So you while understanding distillation, you must have noticed there is no addition of a foreign substance from outside. You have the feed solution, you boil it, and you create the vapor phase. Okay, so the uniqueness lies over here. In distillation, there is no addition of foreign substance. Whereas in gas absorption, for example, we have to add solvent as a foreign substance from outside. Solvent will be added as a foreign substance from outside. Or in case of liquid extraction, again solvent will be added as a foreign substance from outside. But in distillation, there is no such addition. The second phase that is involved, it is created from the first phase. How it is created? The first phase is the liquid phase, the original liquid feed solution. You are heating it so that it boils, and boiling results in formation of a vapor phase. The second phase, that is the vapor phase, it is created from the first one. This is the uniqueness of distillation. Okay, so we are saying as compared to other separation methods, no foreign substance is added in distillation. The vapor phase, it is created from the liquid phase, and how it is created? It is created by addition of heat. It is created by addition of heat. Okay, so in this way we have understood what is distillation. We have also talked about, or I have also talked about, how what is the uniqueness of distillation. Okay, now let us understand it with the help of an example. What is the example? Let us consider distillation of methanol water solution. So we are considering a binary liquid solution. Binary liquid solution contains two components. Which are those two components? One is methanol, the other one is water. Okay, so let us talk about distillation of methanol water solution. Okay, so at 1 atmosphere, let us understand the example. At 1 atmosphere, boiling point of methanol is 64.7 degrees Celsius, whereas boiling point of water, it is 100 degrees Celsius. Okay, so comparing these two boiling points, we can easily say that methanol is the low boiling component. Methanol is the more volatile component. Therefore, methanol shows greater tendency to vaporize. Whereas boiling point of water is 100, and therefore it is high boiling component, or it is the less volatile component. Okay, when the solution is boiled, when methanol water solution is boiled, a vapor phase will be created. The solution is boiled to create a vapor phase. The vapor phase that is formed, it will be rich, or is rich in methanol. Why it is rich in methanol? Because methanol is the more volatile component. The vapor phase is condensed to get the distillate. Okay. So the resulting vapor phase, which is formed, which is created by boiling the original feed solution, that vapor phase is condensed to get the distillate. And distillate, of course, it will be rich in methanol, the low boiling component. The residual liquid, it will contain majority of water. Water being the high boiling component, it will majorly remain in the residual liquid solution, and this residual liquid solution is then separated as bottom product, as we have understood it. Okay, so in this way, methanol and water, they are separated to some extent. Why I am saying they are separated to some extent? Because we have boiled the solution once, and we have condensed the vapor phase once. There is no repetitive boiling and repetitive condensation. That's why the separation is limited. Separation of methanol and water is limited. You can increase the degree of separation by repetitive boiling and repetitive condensation. Okay, so we will understand that as we go into details of distillation. So for time being, I hope you have understood how distillation is carried out. This simple example will help you to understand the operation of distillation. Okay, okay. Now let us move ahead. The next thing that we will discuss is uh, how distillation is carried out. So you can carry out in a batch wise manner, or you can carry out in a continuous manner. Accordingly, you have batch distillation and you have continuous distillation. So we are going to discuss this one by one. First, let us talk about batch distillation. So in batch distillation, a batch of feed solution is fed to a still. What is a still? Still is a vessel in which there is provision of boiling the feed solution. So you start with a batch of feed solution, let us say 100 liters or 100 kilomoles or 100 kg, 100 kilomoles of feed solution is fed to a still. The solution is boiled to create the vapor phase. So within the still, the solution is boiled to create the vapor phase. Vapors, as soon as vapors are formed, they are immediately removed and they are condensed. The condensate is removed as the distillate, as we have already understood. When the vapor phase is condensed, you get a liquid solution, and that solution is distillate. Okay, so the condensate is removed as distillate. After the desired separation, heating is stopped. So uh, when desired concentration of more volatile component is achieved in the distillate, heating is stopped. That means the batch completes. Batch distillation completes. Okay, so that's why we are saying after desired separation, heating is stopped. The liquid left in the still, it is the bottom product. The liquid that is left in the still, it is the bottom product, and the bottom product will be reaching high boiling components. Okay. Important thing to note is separation in batch distillation is limited. Why it is limited? The reason is as there is no repetitive condensation and boiling. There is no repetitive condensation and boiling. That's why separation in batch distillation is limited. Okay. Then once you remove the bottom product, the liquid residual liquid. Once the residual liquid is removed as bottom product, you can prepare for fresh batch, and fresh batch of feed solution will be fed to the still, and then the operation will be repeated. Okay, so in this way batch distillation operation is carried out. Now let us understand this with the help of a simple animated diagram. Okay, so you have this vessel, and in this vessel the feed solution is fed. What is the feed solution? Feed solution is solution of methanol and water. So when you have solution of methanol and water, methanol is the more volatile component. Okay. Once the solution is fed to the still, it is heated. Due to addition of heat, the solution boils and vapor phase is created out of it. The vapors, they are removed. The resulting vapor phase, it will be rich in low boiling component, it will be rich in more volatile component, and in this case the more volatile component is methanol. Okay. Then vapors, they are removed from the operation, they are sent to a condenser where they are condensed to get the condensate, and this condensate is taken out as distillate. And after the desired separation is achieved, the residual liquid is removed as the bottom product, or you can also call it as residue or the bottom product. Distillation, in this particular example, distillate will be rich in more volatile component, that is methanol, and residue will be rich in less volatile component, that is water. Okay. Separation purity of distillate is limited. Concentration of methanol in distillate is limited because there is no repetitive condensation and repetitive boiling and condensation. Okay. So this is the basic, this is the understanding, this is how operation distillation is carried out in a batch wise manner. Now let us understand how distillation is carried out in a continuous manner, that is continuous distillation. So continuous distillation, it is mostly carried out in vertical cylindrical columns. Continuous distillation operation, it is mostly carried out in vertical cylindrical columns that are made up of mostly these columns are made up of metals. Okay. The feed solution is continuously admitted in the column. So there is continuous, feed is continuous, the feed solution is continuously admitted in the column. The feed entry point, the entry point is located more or the less centrally. Entry point feed is admitted at a point that is more or the less located centrally. After it enters the column, what happens? The feed flows down to the reboiler where it is boiled. Reboiler is a device in which feed solution is boiled. Okay. So the feed that enters the column, it flows down to the reboiler under the influence of gravity, and in the reboiler it is boiled. Due to the boiling, what happens? Vapor phase is formed. The resulting vapor phase is admitted to the column at the bottom. The resulting vapor phase enters the column at the bottom. It rises up and is removed from the top. Once it enters the column, what happens? The vapors will be rising up and they will be moving to the top and they will be removed from the top. After removing from the top, the vapor phase is taken to the condenser and it is condensed in that condenser. The resulting condensate, once you condense the vapor phase and you have the condensate is divided into two fractions. One fraction, one fraction is taken out of the column as the distillate or the top product or the overhead product, whereas the other fraction it is sent back to the column. It is sent back to the column as the reflux. Okay. The bottom product it is continuously removed from the reboiler. The bottom product is continuously removed from the reboiler. Now let us understand this with the help of animated diagram. That will make the operation clear to you. So you have this vertical cylindrical column. Feed solution is admitted more or the less centrally. So feed is entering over here, feed solution. Once it enters the column, it flows down. It flows down under the influence of gravity. It flows down to the reboiler. It is taken to the reboiler. In the reboiler, it is heated and the resulting vapor phase it is admitted into the column at the bottom. After entering the column, the vapor phase will rise through the column and it is taken out from the top. Then it is sent to the condenser. Heat is removed in the condenser so that vapor phase gets condensed. The resulting condensate is divided into two fractions. One fraction is the distillate, one fraction is taken out of the column as distillate, whereas the other fraction it is sent back to the column as reflux. Okay. And whereas the bottom from the reboiler, the bottom product or the residue it is continuously removed. Okay. So you can see in this operation there is continuous condensation, or you can say repetitive condensation and repetitive boiling. Okay. So once you have this fraction, the reflux stream enters the column. It goes along with the feed solution. It gets added to the feed solution, and this combined solution goes to the reboiler where it is boiled. Okay. So there is repetitive boiling in the reboiler, whereas vapor phase, which is continuously removed from the top, it is continuously condensed in the condenser. So there is repetitive condensation. Okay. And one more thing, within the column, vapor phase, which is right moving from bottom to top, is in continuous contact with the liquid phase that is moving from top to the bottom. So there is continuous contact between liquid and vapor. There is repetitive condensation and boiling. Therefore, in continuous distillation, in a operation like this, you can achieve any degree of separation, because in continuous distillation you have repetitive condensation and boiling, and that will result in any degree of separation. Okay. So this is all about continuous distillation. So with this we complete our discussion on fundamentals of distillation. So in this we have understood what is distillation, what is the basis of separation in distillation. We have discussed a simple example. Then we have understood how batch distillation is carried out. then we have understood how continuous distillation is carried out. Okay, so in part 2 of the lecture series I'll be talking about material balance for distillation. Okay, so thank you for being with me.